What's C? 3/10. Absolutely right. Does D work? Does D work? Is D a perfect square? No, of course it is not. Where's my circle? That pisses me off. D is not a perfect square, so what must you do? You're supposed to estimate, is the numerator a perfect square? Yes, so can we leave it alone? I'll get that back later. The numerator is a perfect square, so we can leave it alone. Is the denominator? So this is approximately 225 over 49, right? Which is 15 over 7, which is a little bit more than 2, so 2.1 would be a good guess. What about this guy? E. Is that a perfect square? Yep, 0.5. What about this guy? I know that I was pretty clear about how to do this. I'm just wondering why anybody is not saying anything, considering all they would have to do is look at their paper. 1/5. Thank you. Square root of 0? 0. 45. Does it work? Nope. But it's between 36 and 49. So it's 6. And it's almost all the way to 49. So 6.7 would be a good guess. What about this one? There's a negative out in front. So what is it? Negative. Same guess as over here. 121 is perfect. It's 11. 5 over 20. This is a tricky one because a lot of kids say it's irrational. Is it? Of course not, because 5 over 20 is 1/4, correct? And the square root of 1/4 is 1/2. Square root of 8, that's almost 9. So a good guess would be 2.8, 2.9. Everybody good? Excellent. I'm mad that my stupid pen highlighter is gone. And I don't know where it is. I'll get it later. I'll get it while you're writing your quiz. Oh, no, I won't. I will need to get it before. Cube root of 576, that's a little bit more than 512, right? 512's cube root is 8, so 8.2 would be a really good guess. Does that have a perfect square? No, it doesn't, does it? There's a lot of ways you could go about figuring this out, though. Isn't that very close to 1,600? Right? Which the square root of that would be 40, correct? And it's not too far past 40. So there's a couple of ways you could do that. You know that's 40. And then what was left over? 128, right? Does that have a square root? No, but it's a little more than 11, yeah? Does that help you? This is what math is supposed to be, ladies and gentlemen. You're supposed to be using what you know to figure stuff out. How can you figure this out for a good guess? Oh, wait, this was the calculator page, wasn't it? Oh, sorry, my fault. When I do this as a regular page, I make the kids do the same thing as the first page. So this, you just went to your calculator, and what'd you get? Negative 41.6. 6. I said 2 decimal places. 5, 7. Okay. Sorry, ladies and gentlemen, that's my fault. The cubed root of 27,000 is 30. Cube root of 3,375? 15. Cube root of 72,900? 27. Or, sorry, square root. Square root of 100,000? 316.23. 316? Yep, okay. Cube root of 1728. What? Square root of 529. 23. Cube root of 1,000. 10. Square root of 196 over 225. 14 over 15, because they're both perfect. Square root of 125, 11.2? And a bit, because I said 2 decimals. Cube root of 64 is 4. Cube root of 125.5. Cube root of 125 over 27 is 5/3. And the cube root of 102 is 4.6 something. I thought it was 4.7 something, but 4.67 you say? Great. Surface area of a cube with a side length of 15 centimeters. 15. What's the surface area? How big is this? 15 squared. How many sides are there? 6. So it's 1,250, right? No. Yeah. No, 1,350. Wait a minute. 225 times 6 is 1,200 and 1,350. Surface area of a cube with a volume of 216. So if my volume equals 216, but my volume also equals the side cubed, then the side cubed must equal 216, right? How do you get rid of the cubed? Cube root of 216, which is 6. So if the sides are 6, what's the surface area? 6 times side squared, which is 6 times 6 squared, which is 216. What? How can it be 216 and 216? Because one of them is what? One of them is what? One of the 216s is volume, which is measured in what? Cubes. The other one is surface area, which is measured in squares. Yay! Everybody good? Sweet. Turn your page over to 96 while I get my pen thing back, because it bothers me that it's gone. Page 96. Okay. A radical is any expression with that symbol somewhere in it. Okay? They can be added, subtracted, multiplied, and divided. Add, subtract, multiply are all part of grade 10. Divided, part of it I am going to show you, but I'm not going to test you on it. Actually, I lie. I'm going to show you every part, almost every part of division, but I'm not going to give you any testing on it. It's just to get you ready for next year. Okay? But the first three we are going to talk about. Everybody good? Okay. An entire radical. I'm highlighting that because it is different than a mixed radical. An entire radical has only that symbol in it. A mixed radical has a coefficient. What's a coefficient? Does anybody actually remember that word? Pardon me, Charlotte? Nobody knows what a coefficient is? It's the number out in front of something. So 3x, 3 is the coefficient. Okay? So, what does the coefficient do to the thing right beside it? What does the 3 do to 3x? Multiplies. So it's going to do the same thing here. Is everybody good? Okay. Radicals exist in both of these. This one is our goal because this one is simplified. Okay? This is where we're going to. If you're in the 10th grade, you already know how to do this. If you're in the 9th grade, you probably haven't seen it yet. So, I'm going to make a point of saying something to you. Actually, I'll wait a second. Convert this to a lowest terms mixed radical, root 72. Now, previously to grade 9 and 10, if you saw root 72 somewhere on a piece of paper, you would have gone to your calculator and you would have gone square root 72, right? And we would have gotten 8.48. Yeah? And a whole bunch of decimals, right? And we would have rounded that off to 8.5, correct? Everyone agree? But 8.5 is not the right answer, is it? The right answer is the square root of 72, which is irrational, which means the decimal goes on forever and ever and ever and ever and ever, right? So this technically has no right answer that doesn't have that square root sign in it. Everybody with me? Okay, now, we're going to start this really slowly. I know, I apologize to the grade 10s that are very comfortable with this, but the grade 9s, you need to see this. This symbol right here, root 72, is missing something. There is something that is not written there that should be written there, but we don't write it there because math guys are lazy. Kind of like we don't write the number 1 as a coefficient or as an exponent. So there should be that little number 2 right there, because this is the square root of 72. Now, what did I tell you that little number 2 tells us? First of all, what's it called? Who remembers? No, it's a little number 2. It's not a big 3 in front of it. It's a little tiny 2. That is the index. The index tells us something. It tells us how many factors we seek. So when it's a 2, I'm looking for groups of 2 factors. Everybody understand that? Right? Like the square root of 36 is 6, because 6 and 6, 2 equal factors. Everybody's good? Okay. So we know that 72 does not have a square root, right? So here's what we do. Since we are looking for factors, remember how I told you yesterday, we're going to do factor trees, and I'm going to actually show you what they're used for, not like in grade 5 when you just did a factor tree and walked away from it. This is what they're used for. So take 72 and break it down into prime factors. So make the tree, get the prime factors. Just like we were going to, as if we were going to use 72 in a GCF or an LCM question. Okay? So everybody break that down however you want. I am betting that most of you are going to go 8 and 9. And then 2 and 4. And then 2, 2, 2, 2. And you're going to break the 9 down into 3 and 3. So everybody will have gotten there eventually. Everybody's cool with what I've done, yes? Now, what is 2 cubed times 3 squared? 2 cubed is 8. 3 squared is 9, correct? So that is 8 times 9, which is 72, right? So does that not mean that if this right here equals 72, and I want the root of 72, could I not do the root of 2 cubed times 3 squared? Because 72 is the same thing, yes? Everyone agree? Okay, now, if exponents didn't exist, how would I write this out? It would be 2 times 2 times 2, correct? Times 3 times 3, correct? Now, what did that little 2 tell me I was looking for? Groups of 2 factors. Do you see them anywhere? Is that a group of 2? Is that a group of 2? So that means I can take that group of 2 out of there, can't I? Because I'm looking for groups of 2. Can I take that group of 2 out of there? Yes, I can. Now, square root of 36 is 6, right? 6 times 6, I take out 1 6. Agreed? What's the square root of 9? 3. So I take out 1 3. So even though I'm taking out a group of 2, I only seek the one value, don't I? So I've brought out 2 2s, so what is out in front here now? A single 2, right? And now I've brought out a 3. What is out in front here now? 3. Now I've got 2 numbers with no signs in front of them in front. If there's no sign, what do? Multiply. What's 3 times 2? 6. Did I leave anything under the radical sign? I left a 2. And that is my final answer. And that is why it works. All of you that have been grade 10 have been shown this, but maybe you didn't get into why it works. This is why it works. Is everybody good? Now, you will notice that this took a lot of steps, yes? And you will cast your mind back to a time a couple of hours ago, not even days ago, when I said it would make your life very easy if you had these numbers memorized, correct? Watch how much easier it makes it when you have this memorized. 72, I'm going to divide that by 2, because it's an even number, right? What is 72 divided by 2? 36. So doesn't that mean that the square root of 72 is also the square root of 2 times 36? Isn't it? Does 36 have a square root? What is it? 6. So I can bring 6 out right away. And I left a 2 under there. 1 step, 5 steps. What's the difference? Did I know any more math? I didn't know any more math, did I? Because when I did all the long steps, I was just taking out groups of 2, right? Everyone agree? But here, I had that number memorized as a square root. It's not more math. It's just a fact I knew. And I could make my life easier. Yeah? Yeah. All right. So let's do a couple of these. 99, we can do 2 ways. We can do it the long way. 99, what are you going to divide 99 by? You're going to go 9 and 11. Now, can I stop there? I can. Why can I stop there, Avian? I can stop at that one step. Why?
Because you can divide 9 by 3, and you can get a square root.
9 has a square root, exactly, yes? This is the square root of 9 times 11, right? Does 9 have a square root? What is it? 3. So what comes out? 3. What stayed under there? 11. And it's done. Now let's pretend you can't memorize the square roots. You just can't be bothered. Does that affect your ability to do this in any way? No, it just means you'll take longer. Because if you don't have 9 memorized as a square root, you got to go one more, 3 and 3. Oh, there's my group of 2. Everybody understand? So, 75. Can you see the shortcut immediately? Is there a perfect square that divides into 75? 25. Isn't this 25 times 3? What's the square root of 25? 5. So what comes out? 5. What stayed under there? 3. Now, let's pretend you don't have those square roots memorized. That's okay. You break it down. 75. Most of you would probably divide this by 5 because it ends in 5. 15. There's a prime number. 15 is 5 and 3. There are prime numbers. There's my pair. So what comes out? The 5. Is everybody comfortable with one of these 2 methods? Everyone, including my grade 9s? Okay. What's 80? How many of you are making a factor tree for 80? Is that okay? Yep. I, however, know that that is 16 times 5. Does 16 have a square root? 4 root 5. Now, let me ask you this. Would you eventually have gotten to 4 root 5 doing the factor tree? Of course you would have. Right? Of course you would have. But again, I point out, if this is the only thing you're doing, does it matter if you take some time with it? No. What if you're in grade 11 or 12 and this is the first step of a 10-step process? Do you want to take a crap ton of time on that? No. Why? Because it's only the first step and you can only spend each minute once, right? We don't all have Hermione Granger's time twister. Okay? I've had to change that reference because of Harry Potter. I used to say we don't all have Marty McFly's DeLorean, but too many kids don't get that joke. How many of you do not get that joke? How many of you do not know who Marty McFly is? Put your hand up. Be proud. It's okay. It's a movie from 1985. How many of you do know who Marty McFly is? Wow. See, that's why I had to change to Hermione Granger. Everybody knows who Hermione Granger is. Everybody knows in the 5th book that she has the time twister. 3rd book. 3rd book. Azkaban is when she has the time twister. My personal favorite book in the series. Also would have been my favorite movie in the series, but the good Dumbledore died and they brought in the bad Dumbledore, who ended up being okay, but he wasn't as good as the good Dumbledore. Yes. No, Dumbledore was always awesome, but the good Dumbledore from the first two movies died. So they had to get a different Dumbledore in the third movie, and he wasn't as good. My favorite thing is when you rewatch Harry Potter, the fourth one, and you realize that Cedric Diggory is a vampire. Cedric Diggory is Robert Pattinson from Twilight, but he wasn't famous when he did that movie. My daughter thought that was very funny because she had seen Goblet of Fire before she saw Twilight, and then she saw Twilight, and she was like, Cedric Diggory's a vampire. I thought it was pretty funny. Anyways, back to math. Now, here's where you can start thinking for yourself. 300 is just 3 times 100, right? So what's the square root of 100? 10. So what's this? 10 root 3. See how fast you can do these? Now, let me also add this to the mix. From now on, 90% of the time you see a square root sign in math class, you will not be evaluating it with a calculator. Do you understand what I'm saying? 90% of the time, from now on, you will leave them like this. Do I make myself clear? Just like in pi, we stopped doing that, right? We don't write 728.3795827. We write something pi. It's just like that here. Everybody good? Great. Carry on. What's this guy? What's the shortcut, or what's the factor tree? 9 times 7. So what's coming out? 3 root 7. What's this guy? 16 times 2, right? So what's coming out? 4 root 2. Now, I want to do something here that might mess you up. A lot of you probably went 4 times 8, right? And 4 is a perfect square, doesn't it? So you would bring out 2 and you'd leave an 8 under there, correct? But 8 is 4 times 2, right? 4 has a perfect square, so what would come out? 2, and there was already a 2 out there, so what do we get? 4, and what we leave under there? 2. Same answer. Everybody good? It's just like fractions. You have to keep going until you can go no further. Everybody with me? Okay, 363 is tricky. Yeah, it's 121 times 3. What's the square root of 121? 11 root 3. Can everybody do the easy ones? Everybody? Everybody can do these when they're simple like this. Do you think it changes in any way? No. Turn the page over. Now, write as an entire radical. What does that mean? What is an entire radical? How does it look? It's just got the square or the root sign with something underneath. So this one has a coefficient. I'm not allowed to have that coefficient. If there is 1 2 out here, how many 2's had to be under there? 2 of them. So this is really the root of 5 and then 2 2's. What math are all those numbers sharing? Multiplication. So this is 5 times 2 times 2, which is the square root of 20. Everybody good? Now, I'm going to give you the gift of a little shortcut. 2 root 5, right? What's the thing that is missing from this that we didn't write down? The index. And what is that index? It should be a 2, right? Look closely at what that looks like. What does 2 and that little 2 there look like? It looks like 2 squared, right? What did we put back under there? 2 squared. So what am I putting back under here? 2 squared. Everybody understand? Okay, so what's this one? What's going back under that? 7 squared. 29 times 49. I can't do that in my head. Well, I can, but I don't want to. It's 880. It's 20 by 40 is 800. 20 by 9 is 360. That's 1160. 40 by 14 something. 1421. Okay, now I'm going to change this one a little and see. I'm going to say that's a cube root. So now I have an index of 3. So what does that mean is going back under there? There was already a 4, and then what? 6 cubed, which is 216, times 4 is 864. Is everybody good? All right. Now look at D and think carefully. You already should have noticed that exponents and radicals are fairly closely related, yes? So this negative, it's there, but is it part of the 5? No, why not? There's no brackets. So what really came out from under there? 12 times 5 squared, yes? 12 times 25 is 300, correct? But what have I forgotten here? That whole thing is negative, and that negative has to stay out in the front. Is everybody cool with the easy ones going both from whole to mixed and from mixed to whole? Everybody's good? Okay, practice a little bit. What's different in A that we haven't done yet? There's a little 3 there. The index is a 3. So it doesn't do me any good to find perfect squares, does it? I would need to have my perfect cubes memorized. A great many of you do not, so you're going to break 54 down, aren't you? Who would like to give me their first step in the breakdown of 54? 9 and 6? Then what? 3 and 3 and 3 and 2. What do you see right there? A group of 3 threes. So what comes out? Not 3 threes. 1 3. And what did we leave under the radical sign? A 2. I have to remember the index. Now, could you have done this with a shortcut if you have the cubes memorized? Yeah, because that's 27 times 2, right? And what's the cube root of 27? 3. So out would come a 3 and a 2 would stay under there. Is everybody good? Okay. Let's break down 144. 144. Most of you are probably going to go 12 and 12, right? Still no group of 3. 3 and 4. 3 and 4. Still no group of 3. 2, 2, 2, 2. Now is there a group of 3? Where is it? 3 2s are gone. So what comes out to the front? 2, and what stayed under there? A 3, a 2, and a 3. What's 3 times 2 times 3? 18. And it's done. Is everybody good? You try C. What's different? There's a 4. So how big a group am I seeking this time? A group of 4. Does any method change to find that group? No, you break it down the same way. I'll wait a second and let you try to break it down, then I'll ask for a volunteer to tell me what they did. Would anybody like to tell me how they started? The tree gets big, doesn't it? If you do a factor tree, right? It gets pretty large. What did you start with? 2 and 64. 2 and 32. 2 and 16. I'm going to stop there because I have been practicing math a lot longer than you, and I know that 16 is 2 to the 4th power. There's a group of 4, right? So what comes out? 2, and what stayed under there? 2 times 2 times 2, which is 8. Now, remember I told you I am always going to give you things that you can do to make your math life easier. They're not shortcuts, because I don't teach shortcuts, because shortcuts are no good. The shortcut is only good if you know how to get there without the shortcut, because then if you forget the shortcut, you're screwed, right? So, as always, I'm going to give you another piece of advice. Some of the advice I've given you already is estimate always. Memorize some square roots. Memorize some cube roots. Memorize your times tables. The other thing I would memorize is 2 to the x. Know the 2 powers. 2, 4, 8, 16, 32, 64, 128. I would know 2 at least that far. 2 squared, 4. 2 cubed, 8. 2 to the 4th, 16. 2 to the 5th, 32. 2 to the 6th, 64. 2 to the 7th, 128. If you can memorize further than that, even better. Because all of you should be recognizing how powerful the number 2 is in math. Let's move on to 162. Oh.
What if you did, I did 32 times 4 instead, and then for the number inside the root, I got something else because it's not 2 times 2 times 2.
Okay. If you had the 4th root of 32 times 4, and you stopped there, you don't have a group of 4 yet. I don't really know what you're asking me, is what I'm trying to say.
No, instead of doing 64 times 2, I did 34.
32 times 4. Okay. So you were at this spot. Do you see a group of 4 there?
No, after I did it, I saw a group of 4.
So the next thing you did was what? 8 times 4? 8 times 4 is fine. Now stop there. If you got to there, you might have seen that this is 2 times 2. And this is 2 times 2. Right? So there's a group of 4, right? So you would bring out 2 times 2 and 2 times 2. You'd bring out a 2. And you'd be left with an 8 under there. It's the same answer, Sale. Avian.
So once you break it down to 64 and 2, why don't you divide 64 by 8 times 8?
You could do that too. Of course you can. If you break 64 down to 8 and 8, you still don't have a group of 4, unless you recognize that this is 2 times 2 times 2. There's a group of 4, so out comes a 2, and you left an 8 under there. I can't make this, I don't know how to make this clearer. I've talked about the factor trees a lot. Does it matter what order you do them in? No. As long as you recognize that you need groups of whatever group you need. But you have to keep going until you get to that group. 162. Let's do this one. What are we going to break 162 down into? What are most of you going to choose for your first number? Why 2? Because it ends in a 2. 81 and 2. And if you have practiced math for long enough, you can stop right at 81. But most of you won't have. Most of you are going to break 81 down into 9 and 9, I would think. And then you should be able to stop, because right there you should recognize what is 9? 3 and 3. What is 9? 3 and 3. Is there a group of 4? So what's coming out? 3, and what stayed under there? What stayed under there? Say it louder, Trinity. Underwear! Ah, I made Trinity say underwear. Okay. Thank you, Trinity. Makes me happy. Now, you will notice I've put these two right beside each other, yes? Because the 108 and the 108 are the same, yeah? Now, I forgot to tell you guys something. We know what the 3 is. It's called the index. The 108 is called the radicand. The only reason I tell you that is because if you're reading a textbook or you're doing a test or something like that, or you have another teacher, he or she might use the proper words, right? He or she might not be saying, oh, what's under there, to make you say underwear. He may not do that. I, however, am not that person. But, to be fair, I would like to let you know the real name of things. Okay? And these are called the radicands. So, you will notice that 108 and 108, I have the same radicand there. Are the answers going to be the same? No, why not? Because the index is different. In E, I'm looking for groups of how many factors? 3. In F, I'm looking for groups of how many factors? 2. What is going to be the same? The factors that I use to find those groups, yes? So 108, most of you are probably going to divide that by 2. 2 and 54. Then, if you've been paying attention today, since you're looking for a cube root, you would go 2 and 27. And why could you stop there if we were doing E? 27 as a cube root. What is it? 3. So what's coming out here? 3. What did I leave under there? 2 2s, so it's 4. Yeah? Okay. Now, what about over here? What size group am I looking for over here? Groups of 2. Well, I've got a group of 2, don't I, already? So what's coming out? 2. But 27 can go one smaller, 9 and 3. Why can I stop there? 9 has a square root. What is it? 3. So what's coming out here? 3. And what did we leave under there? A 3. But what do I have to do with this 2 and 3 running out there? Because it's not 23. What is it? 6. Is everybody good? Which 3 where? No. The 3 is the other factor I brought out. I brought out the 2 and the 3. Is everybody good? Yes? That was what was left here. If I stopped right there, 27 as a cube root of 3, and I left 2 and 2 under there. 2 times 2 is 4. Now, all of you should be aware that if I leave this much white space at the bottom of a page, I'm going to do something with it. Root 64. What is it? 8. Great. Why? Because 8 times 8, right? It's a group of 2. Everybody good? Okay. Root of x squared. What is it? Why? because x squared is x times x. That's a group of 2. Everybody good? Yeah? Okay. Root of 64x squared. What's that? 8x, because this was 8, this was x, so together they must be 8x. Agreed? Okay. Root of x cubed. See, this is what I'm talking about, right? This is math. Every one of you should be able to tell me that answer without even thinking. X root x. Why? What is this? X, x, x. There's a group of 2, so what's coming out? X, and what do we leave under there? Everybody good? Okay, so now all of you should be able to do this. The root of 128 x to the 5th y cubed. All of you should be able to do that already, based on what you just said. I'll let you play around with it a little bit. All right. This is really 2 times 64, right? X squared, x, y squared, y. Correct? Does 64 have a square root? What is it? 8. So what comes out here? 8. X squared, is that a group of 2? So what comes out? An x. Is that a group of 2? So what comes out? Another x. So they're taken care of. 64 is taken care of. Is that x a group of 2? So where does he have to, can he come out? No. Is that a group of 2? So can it come out? And what did I leave under there? 2xy. And would I write this way? How would I write this? 8x squared y root 2xy. Is everybody good? Does everybody understand what I did there? Is everybody ready to see a shortcut that will help them if they understand this? Because it's not really a shortcut. Root 128x to the 5th y cubed, right? And what number should be here that isn't here? 2. So I know I should be pretty comfortable with the numbers, right? 2 times 64, take out the 8. Yeah, I'm going to forget about that. This helps you with the exponents. If I'm looking for a group of 2, then what do I got to do to 5? I'm looking for groups of 2. What math breaks a number down into groups? Division. 5 divided by 2 is what? 2 with one remainder, right? So that means x squared comes out and an x one remainder stays in there. What's 3 divided by 2? 1 with one remainder, right? So 1y comes out and it left a remainder of y under there. And then we already know how to do the numbers, right? Everybody good? What if I changed this to cube root? We know how to do the numbers. We'd be looking for groups of 3, right? Right? And we know that that's 2 to the 7th, yeah? Right? So if that's 2 to the 7th, x to the 5th, y to the 3rd, what do I do with the 3? What is 7 divided by 3? 2 with 1 remainder, right? So out here will come 2 2s, and what will stay under there? 1 2. What's 5 divided by 3? 1 with the 2 remainder, so it will come 1x, leaving what underneath? 2 x's. What's 3 divided by 3? 1, so it will come 1y, leaving any y's under there? Then I put my sign back in. Would I leave 2 squared written that way? What would I write it as? 4xy cube root 2x squared. Can everybody do this with exponents now? It's not any different, is it? Because the exponents are just groups, right? Is everybody good? Sweet. Take what you know and do those 3. It's on radicals and exponents. $64.80. Is that right? Yeah? $8.75, right? Is everybody good? Everybody can work both ways. Everybody can work with exponents. Which part? Which, like here? Doing this is where you're having trouble? If there's 1 3 out there and I was looking for groups of 3, Sahil, how many 3s had to be under there? If I took out 1 3 and I was looking for a group, how many had to be under there? Okay, dude. Everybody else, you are working on page 98, 99, and 100. That's what you're going to work on. I know your break is literally in 5 minutes, but you're going to have time afterwards. So, can you do this? The square root of 48. Do you understand how to do that? How would you do that? You just told me 1 second ago. You looked me right in the eye and say you understand that. How would you do that? You'd factor it. Awesome. Great. So start factoring. 48 breaks down into what? 6 and 8. Then what? 3 and 2 and 2 and 4. And then 4 breaks down into 2 and 2, correct? So the root of 48 is really, once we go through this, is really the root of 2 to the 4th, 1, 2, 3, 4, times 3, correct? I am looking for groups of 2, right? Is there a group of 2 2s there? How many? 2 of them. So I'm going to bring out 1 2, and then I'm going to bring out a second 2, yes? And what did I leave under there? 3. What is 2 times 2? So this, the root of 48, is really 4 root 3, correct? Now if I want to go backwards, there's a single 4 out here, right? Agreed? Which means under here, this is 2 times 2, which is 4, and then 2 times 2, which is 4 again, yes? So there were 2 4s under there. So if there's 1 4 out here, how many 4s were under there? Right here. There's 2 4s under there, right? If I have a 4 out here, I had to have 2 4s under there to take them out, yes? So if I have a 3 out here, and I'm looking for groups of 3, how many 3s had to be back under there? 3 of them. Here, I was looking for groups of 4, and I have a 6 out there. So how many 6s had to be under there? 4. Here, I'm looking for a group of 3, so 5 3s. So what about this one? You don't have to do it. 2 7th root of 2. How many 2s have to be back under there? 7. So this would be the 7th root of 2 times 2 to the 7th. And 2 and 2 are the same base, right? So what do I do with the exponents when I'm multiplying? What do I do with these exponents when I'm multiplying? Because they're the same base. I add them. So this would be the 7th root of 2 to the 8th. Okay? Okay. Everybody else, you are going to have 20 minutes to work on 98, 99, and 100 after the break. After that 20 minutes, I'm going to ask if everyone is ready. I'm going to ask if anybody had any troubles with 98, 99, and 100. All of you are going to say, no, you got them perfectly. Then I'm going to give you your quiz, which you are all going to score 100% on, because none of you asked me any questions when I gave you a chance to. Okay? Charlotte. 5A is a tricky one put there just to mess with your head to see if you were confident. Isn't 105 3 times 5 times 7? And doesn't this say I'm looking for groups of 2? Is there a group of 2? So does that get any simpler? So you leave it. It's just to see it. The reason it's there, Charlotte, is because very often you people learn steps to do without thinking about what's really happening, right? The point of changing to a mixed radical is to make it simpler, correct? Well, it can't get any simpler. Just like if I gave you this fraction, 17 over 53. Does that get any simpler? No, because they're both prime numbers, so you leave it. Oh, there's the bell. I will see you back here in 10 short minutes. It will be so short. I will miss you so much. I know you think I won't, but I will.
This question here, what did I do wrong? It's like if you do the square root of 96.
You didn't do anything wrong. What's the square root of 49?
Square root of 49 is 7.
So you bring out a 7, right? You already have a 2 out there. Plus, I told you to memorize the square root. So what's the square root of 196? 14. Yes.
May I have one of these?
I don't care, yes. I will only make a little bit of fun of you. Indeed.
Do I leave it like this?
No, there's nothing under there. It's just 14. Because the square root of 196 is 14.
So I just write equal 14.
You just write 14.
What about right here? What do I do with the 2 and 3? Do I multiply?
You multiply them because they're coefficients.
This is right.
2 times 3 is 5?
No, right here.
What did groups it out?
Pair
What did groups it out?
Oh, yeah. So you're bringing out... Oh, I see. I'm sorry. Yes. 2 stays under there. Group of 5s comes out. It's perfect. Nice job. You must have had a great math teacher. This is where you say the name of your teacher at your real school. No, stop it. Hey, how are you? Is this Kirit related to you? Kirit. He's got the same last name as you. I was just wondering. Okay.
Is that your cousin? Your cousin? Are you sure?
Well, I think he'd probably be pretty sure.
Mr. Myers.
Jimmy.
I got 2. Here's
Right.
7 and 2.
So out comes a 2, out comes a 7. What's left under there? Nothing. Because the square root of 196, Jimmy, is 14. Right?
So leave it the same?
14. That's the answer. Yo.
Will this be correct?
Would it? Did you break it down?
Yeah.
But it's not, because 27 has a cube root. So what's coming out?
27 is
3 times 3 times 3, right? So what's coming out?
3,
3. What stayed under there?
2
So cube root 2 stays under. What do you do with the 3 and the 2?
times it, so 6.
There you go. Now it's right. Yo. For what? 97B? This one? Yeah. 12 times 12. 3 times 4. 3 times 4, right? 2 times 2. 2 times 2, right? So I have 2 to the 4th times 3 squared, yes? I'm looking for groups of 3, yes? How many groups of 3 can I get out of there? I can get 3 groups of 3 out of 4. I can get 1 group of 3 out of 4. Okay, I'm going to write this out the long way because you appear to be having issues. That is 2 times 2 times 2 times 2 times 3 times 3, correct? Do you see a group of 3 in there? Where? Right there. So what comes out here? 2. What stayed under there? 2 times 3, which is? What's 2 times 3? And what's 6 times 3? 18. Well, I know you're both learning it, even though I taught this personally to both of you 2 years ago. No kidding. What are you taking, Sian? Biology? Ladies and gentlemen, I'm recording all of the work up to page 100, so it will be on YouTube if you wish to check it over later with me going through it if you don't want to ask now. Yes.
Of like getting the mixed radical into the entire.
So if there's a single 3 out there, how many 3s were under there? Group of 2. So 2, and there were two 3s under there. What's 3 times 3? Times 2? Root 18. It is this part right there, top of page 97. That is the timer. Are people feeling they need another minute or two? Okay, 5. Oops, I just made that a 5-second timer. Yes, Jimmy.
Are we going to be able to use the perfect squares?
No. That's why I said memorize.
What's our
Ms. Carr. You can use your calculators for your quiz, of course, but you're not going to give me any answers in decimals because you're simplifying radicals.
Mr. Myers, for the number line question for cube root of 10, I just estimated it to 2.1.
Absolutely right. There's the timer. All right. On the screen behind me is page 98. 14. 6 cube root 2. 5 fourth root 6. Any questions about those? How do you get which? I haven't even gotten to F yet. Any questions about those three? Going once. Going twice. Going thrice. Awesome. I can't wait to mark this quiz. Any questions about E and F? Okay. If there was no negative 2 there, Erlen, what would you do with the root 180? Jimmy? I'll go over E in a second. What would you do with the root of 180? You would break it down. 180 divided, I would do 18 and 10 because it ends in 0. Right? But it doesn't matter. So you're going to keep breaking it down. 9 and 2, 2 and 5. Now I'm going to stop there, right? Because there's a group of 2, so out comes a 2. And that has a square root, so out comes a 3, yes? And we left a 5 under there, correct? Now what do you do with the 2 and the 3? Multiply them. Okay. But there's already something out in front. So when these came out in front, we multiplied them. What do you think we do with that one? Multiply it. Math always is the same. If there's a number out in front, it multiplies. There's a number out in front, so we multiply. Negative 2 times 2 is negative 4. Negative 4 times 3 is negative 12 root 5. Okay? Now, Jimmy, E is exactly like every other one. You just break it down. Since it ends in 4, I believe that most of you would divide it by 4. Or by 2, I mean. So, with your calculator, you find that as 192. That divides by 2 again to get 96. That divides by 2 again to get 48. That divides by 3 to get 16. Now, why am I stopping at 16? I want square roots, don't I? Does 16 have a square root? What is it? 4. So out comes a 4. So 16 is taken care of. What do you see right there? A group of 2. So what comes out? A 2. What do I do with those two numbers? Multiply them together to get 8. What did I leave under there? 2 and a 3. 6. Okay? Now, where you're going to make mistakes is rushing. For example, one of you came up to me and you'd done a whole factor tree and it made no sense. Because one of your factors way up near the top, even though you used your calculator, the calculator gave you 375, but you wrote 275. Right? Check your work, pay attention to detail. And before you start taking groups out, make sure that it multiplies up to the radicand. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and then you check, is 24 times 16 384? And if it is, then you can start taking your groups out. Does everybody understand? Okay. Page 99. You had to put them in a number line without a calculator, so you weren't allowed to find the decimals. So the best thing to do is put them back to full radicals. Then you can quite plainly see the square root of 28 is obviously the lowest number there. So that would go where on a number line? On the left or the right? The left, because the small numbers are on the left of a number line. Then you had a bit of a gap. Then you had 3 that were very close together. Then you had a bit more of a spread out to this guy. But I don't even care if you did that. As long as you put them in the right order, that's all that matters. Down here, what screwed you up? A couple of things. 1, 3 root 4. What is the square root of 4? 2. 3 times 2 is 6. So this you didn't even need a radical for. This guy, cubed root of 10, is pretty darn close to the cubed root of 8, which is 2. So this guy must be pretty darn close to 2. So that's 2. That's 6. This is the square root of 52. And this is the square root of 180. They're obviously the big ones, so they're out on the right. There they are. And these guys are on the left, where the little ones go. Everybody good? Excellent. And page 100, it had all the answers there, so of course you could check your work. But is there anything on page 100 that you wish to ask me about before I give you your quiz? Charlotte. Number 16. Anything before number 16, because I'll build up to yours. 14. Anything before number 14? Jashin. 11G. J, as in Jashin. I'm going to learn. I'm working on it. All right, 11J is right there. Cubed root of 375. Break it down. Cube root of 375 breaks down into 3 and 125, doesn't it? Doesn't 125 have a cube root? 5 times 5 times 5. So out comes a 5, and you leave a 3 under there. What? 12G. 12J. 2 cube root 9. If there's 1 2 out there, and I was looking for groups of 3, how many 2s are under there? 3 of them. So it's the cubed root of 9 times 2 cubed. 2 cubed is 8. 9 times 8 is 72. Okay? Okay. Next was 14, I believe. Yes? Okay. So, if this is a square, what do you know about the sides? They're the same. And they must be the square root of 252, correct? But 252 doesn't have a square root, so simplify it. 252 divides by 2 to get 126, yes? Then it divides by 2 again to get 63, yes? Then that is 9 and 7. Why did I stop at 9? Because it's got a square root. So what comes out? 3. Is that a group of 2? So what comes out? 2. What did we leave under there? 7. What do we do with the 3 and the 2? What's 3 times 2? 6 root 7. You good? And Charlotte, you were 14, yes? 16, sorry. A square has an area of 54. Determine the perimeter. So if the area is 54, what is the side? The square root of 54, correct? Okay. 54 doesn't have a square root, so we break it down. It's 9 and 6, yes? What's the square root of 9? 3 root 6, yes? Now, how many, so this side is 3 root 6, yes? How many sides does the square have? So what do I got to do with this? Multiply it by 4. Number out in front, number out in front. They're both coefficients. What do they do? To get 12 root 6. Done. Now you will notice, ladies and gentlemen, that the last few questions here required you to make some assumptions about math, yes? Based on what you already know. There's numbers out in front, they all multiply together. Right? What's our next topic? Multiplying and dividing radicals. We're going to move on with this. Everybody cool? All right, I'm going to give you this quiz. Okay, 5 multiple choice exponent questions and 9 simplifying radical questions. The first 6 are just numbers. The last 3 have some variables. To remind you, This stuff right here, you're just looking for groups. Everybody good? Yeah, all right. How do I want to handle this today? I'm going to trust you to mark your own. Again, you don't need to do a code name and switch with somebody. Even though I don't know why I don't just make you switch with somebody, because you all tell each other what you got anyway. And everyone's like, oh, I want it to be private. And then as soon as the test hits your desk, what'd you get? Oh my God, I got 17. I thought you wanted it to be private. I do. But you just told everybody in the loudest voice you have. But it's still private. I only told my friends. Oh. But you said, oh my God, I got 17. And the whole class heard it. No, they didn't. It was private. Okay. But I will let you mark your own, because if you cheat, I just find out on the test anyway. And then you look kind of silly to tell me you got 20 out of 20 on a quiz and then get 5 out of 100 on a test. Not that any of you would ever do that. Because like I said, eventually I'm going to find out. Make sure you put your name on it. People that are bad at putting their names on things. No names mentioned, Jasper and Shima. You didn't write your name on your last test. Oh no, I've left the board visible. Whatever will I do? Oh.